So every team actually you design the floor. If you finish it, you copy, right? So so I assume that every teams easily you could build 40-story building. Just in case, if you haven't done it, here edit story, you could set it up the floor height. Here, this building is 660. Okay. For to make it simple, we assume 15 feet height. Right. So this is all the story information here. But grid is you could play grid here. So this is what we discussed already. Now I try to show you how to set up the wind load. So go to define, right? Go to define and load pattern. So I'm gonna set up the load here. First of all, I'm gonna set the wind and choose the type wind and choose the auto lateral load. AC7-16. So I'm gonna modify. Oh no, I have to add it first. Go define lateral load. Oh. Winds and AC7-16. I need to add, right? But should not include the self-weight multiplier. So I just create the load pattern and modify here. You need to plug in all the design wind parameters. We talk about the ultimate load 115 psf mile per hour, 115 mile per hour, right? Exposure B, ground elevation factor, topographic. I just assume that 1, and I just keep all the default, but I just change the wind speed, and I'm gonna just say okay and go. Now the thing is, we need to tell also we need to use another the idea because a wind because the building is discrete has a floor. We usually calculate the wind loads based upon, right? As I said, the wind pressure times tributary area. So we lump each wind load on each flow level. In order to do that, we need to let ETAPs know what is our building width, right? X direction, Y direction. They have to understand width and height so that pressure, design pressure times tributary area, which is width time flow height, right? So in for wind load calculation and also structural the 3D analysis standpoint, we treat each floor made out of metal than concrete slab, right? Relatively infinitely stiff. So this is our slab, right? We have column in plane, right? In plane means, yeah, obviously any kind of maybe displacement within this plane is stiff. We call this is diaphragm. We're using diaphragm, but it's rigid diaphragm. So that means we simplify any node, any place we have plot right? The node within this diaphragm work is by the motion. So obviously this plate is moved either globally together x, y, and push. Right? We don't really consider right any intermediate displacement within this slab. Why? Because concrete and typically it's a large, right? As you mentioned, and still in plane fractions. So we usually try to simplify our model first because we should try to save some computation time. And computer currently you are using it, it's well advanced, but 20, 30 years ago, You don't even have a computer, personal computer, right? I started my career in 1999. Personal computer, yeah, I've been using plus minus 19, yeah, 2000, 1990, yes, right? And but software, right? E-types came out years, no, Set 2000 came out 1999. E-types came out year 2000, right? Before IBM, some big company had their own software. Think about that period of time. We're using a lot of calculation. Means also if we have some computer software, we're trying to simplify them out. Otherwise, these computers model cannot run, right? So again, this computation effort, we try to minimize so that the all theoretical significance or non-significance we need to implement it in our modeling, right? Phase, which is I think this is a one kind of very the important because since we assign all the nodes on each elevation at each diaphragm, it saves a lot of computation time. So, for example, let's say here I'm gonna select because ETAPS has some nice feature. Let me see. I select all this. I'm gonna assign these diaphragms. So go to assign join and diaphragm. So DI is default diaphragm. If you click it, there is a ridge diaphragm and send me ridge diaphragm type. So I'm gonna keep the ridge diaphragm and assign. When you assign it on the plan, you'll see that all the nodes on its elevation, right, is high. It show assigned to diaphragm. So this is one elevation. Every elevation or any node right there, right? I'm just going down. I'll put it in 3D. See that all diaphragm is assigned. Let me see on elevation. So every floor has a diaphragm. Let me see that. Yeah, but base. Yeah, because I select all the nodes, but base. Oh, I don't need this diaphragm, so I'm gonna discontinue. Diaphragm. This one there. So at the base foundation reaction, because I already boundary condition, I don't need a diaphragm. So when you go up, now you're gonna see the diaphragm, right? So this doesn't, this checkbox doesn't. So I'm gonna turn on the diaphragm extends. So every floor I'm working, right? I'm working. I think every diaphragm is assigned. So now it's time to run. Since I set up the wind load here, and I just open. Come on, come on, what? Oh. And yeah. So this is the actually place they ETAPS recognize overall building width from this diaphragm assignment, but since I didn't run the analysis, it doesn't register. So first of all, I'm going to run this model. So what I'm showing here today, based upon wind load, right? We talk about lateral system. This is one example. You guys actually have your model. You're gonna define the lateral wind load, right? And in order to do that, there are a few steps you need to apply, right? This is diaphragm you need to assign. So I'm just going back to define and check the load pattern, wind load, modify, and but okay, let's check the wind load here. Okay, so here maybe I'll show you first of all story shear. So I just run the wind load. Display lot displacement and wind load. So typical default, we have a total 12 load cases. One here, step number one is wind load, wind blowing in X direction, global X direction, and two is Y direction, and 3 to 12 has something combination of X and Y and eccentric. So first of all, we're gonna pay attention wind load blowing X direction. See that blue line, right? Wind is blowing in X direction, right? Current model is shown based upon your wall thickness. I see that total deflection is 25 inches here, right? We haven't sized anything yet, just using default, maybe 12 inches. Concrete strength, we haven't done anything. Just what I tried to show you, just how to define, set up the wind load, right? And try to apply the wind loads, but in order to do that, you need to define these diaphragms. So ETAPS register what is a building width in X direction, Y direction. So, and floor to floor height using width and height, and using wind pressure, they can calculate total wind load each floor, right? If I type 2 is wind is blowing in Y direction. So you see the global Y, red color, you see 32 inches. I think this is beyond our limitation. I think mostly 660, right? 660 divided by 400 or 500. We maybe end up with what? 16 inches, 18 inches, something like that. But I think we haven't sized any wall yet. So that's the next step we're gonna do. So I'm just going back to here. So maybe let's see what is the significance. Yeah, this is a wall system. Okay. So the deflection wise, if you're interested, this. Okay, deflection, right? Wind, X direction. You can see first of all, again, when you create an feature and feature, there's always have some validation, right? You maybe make mistakes a lot. So, but you need to know how to catch up your mistake, right? You maybe assume that perhaps I assigned the window, but somehow you didn't assign diaphragm, then it just doesn't generate the window. How are you going to check it? By using reflection diagram, right? Forces continuously, you need to check up, make sure you properly assign everything, and then you move on to next, right? So this is the X direction. I will show you Y direction and then try to wrap up. So Y direction, in the second Y directions, you could see this. If you may have some geometry disconnected member, you will see that building members applying each other. But I want you to just check the displacements, make sure everything is connected and working like globally. So you should at least always double check your model before you move on to next step. So This is just, I show you the example of how to set up the wind load, and I'm sure they have to show. Somehow new version doesn't show it, so let me click, 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 click. Oh, okay, now here I just click this, somehow new version doesn't automatically set up. So based upon once I define the real-time diaphragm, right? I select basically all the nodes on each floor. Based upon this diaphragm, they calculate the building width and depth along the height, right? So Itachi is smart, once you define clearly, they calculate what is the building width and depth. So when they calculate the wind load in X direction, Y direction, they use this, the building informations. Okay, I think that's